Okay, now move on to question 17 of permutations, combinations, and probability. We won't bother with probability in this one, or with combinations, just permutations are going to be needed. So I'll read the question out. How many different numbers can be found using 1, 2, 3, 4, 5 if each number contains one or more digits and no digit is repeated? That's the first part. And the second part, out of all those numbers, how many of them will be multiples of 4? So the first part, I'll slog it out the long way to try and avoid any sophistication which might confuse you. And first of all, let's see the number of one-digit numbers. One-digit numbers. Well, there'll be 5 of them. Okay, 1, 2, 3, 4, and 5, each taken individually. For 2 digits, we need the number of permutations of selecting 2 from 5. So that will be 5p2, which works out to 20. And similarly for the others, 3 digits would be 5p3. That works out to 60. 4 digits, again the same sort of procedure. 5p4 this time, which comes to 120. And lastly, 5 digits, which is 5p5, which works out to 120. Okay. Right. Adding all this little bunch up comes to total equals 325 altogether. All right. Okay. So that deals with part A. We now move on to slightly more difficult, I think, of part B. We've got to sort out what sort of numbers will be divisible by 4. Well, the solitary, so how many are divisible by 4? Or multiples of 4? Well, there'll be the solitary digit 4 is one of them, okay, is 1. None of the other solitary digits would be divisible by 4. The rest of the multiples of 4 must end in as 12, 24, 32, and 52. And we need to get proceed from there. Right. So we need to find out how many ways there are of filling the 3 spaces, some of which may be empty, of course, to the left of 12, 24, 32, and 52. So that's 3 spaces. So we proceed as we did in the first part. So 1 digit, we just use 1 digit, will be 3 digits to spare, so that's 3. 2 digits will be the number of permutations of 2 objects out of 3, and that's 3p2, which is 6, and 3 digits in a similar way, 3p3, which is 6. And they add up to 15. Okay, 15 altogether. But these are associated with, each one is associated with a number ending in 12, 24, 32, and 52. So we multiply 15 by 4. The 4 is coming from there, 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 and there. And that comes to 60. All right. The numbers 12, 24, 32, and 52 themselves, which are permitted, 12, 24, 32, and 52, makes another 4. And we had the 4 at the beginning itself makes 1. So we just add up 60, 4, and 1 and come up with a grand total of 65 altogether. And that answers the second part of that question.